right. Try that again. All right. Hello, everyone. Thank you for joining us for this next talk. We have avoiding the $1.5 billion Bybit attack via the Superworld computer framework. We're going to be seeing how to build the future in a decentralized world. Please welcome to the stage Zhou.
Oh, I've got the mic. Hello, everybody. It's my great pleasure here to share some technologies to avoid the recent 1.5 billion attacks by Bybit. So my name is Qi. I've been working in this space for about 7 years. Before that, I was a software engineer at Facebook, Google. And my primary interest is in Ethereum infrastructure, including layer 2s and data availabilities. And so I have received a couple grants from Ethereum Foundation and also like Optimism. Bybit was, everybody perhaps know that was attacked, lost about 1.5 billion fund. And we just discovered the root cause is that it's the front end of the safe multi-sig wallet was maliciously replaced by the attacker so that it will sign a malicious transaction that replaces the ownership of the multi-sig wallet of the Bybit. And then once the Bybit co-signers, including their CEO, Ben, signed the transaction, they did not check the actual intention of this transaction and just believe what the safe front end running on their servers returns. So this malicious transaction then replaced ownership of the contract to the attackers, and the attackers then drain all the 1.5 billion Ether to their own account, which marks the largest financial attack in our human history. So one natural question, especially flying around in trees, is people are asking, is Ethereum still safe? Actually, it's not. Ethereum is still safe, but we are missing one key point, is that the front end of most of the app applications are not protected by the Web3 or the Ethereum consensus. They have to rely on centralized components, including DNS, centralized servers. For example, Safe is a perfect case. There's a couple of other examples like Uniswap and Tornado Cash, which all of them now using DNS and running on top of centralized servers, which become the central point of failure that our centralized systems are facing. For example, all the data that we retrieve from the centralized servers it's very hard to verify its integrity. In the case of the Bybit attack, the front end was maliciously replaced, and nobody is aware of that because it's running on a centralized server. Second, all the replacement happened into those centralized servers is opaque, so that all the history of those changes cannot be found unless we have to rely on third-party Internet Archive service to periodically check the historical web page of the safe and figure out when it was changed and how it was changed, which is really unreliable. And lastly, it cannot guarantee availability. It can be easily censorship attacked. For example, some centralized exchanges, like front ends like Uniswap, are reported to refuse to serve some restricted areas because of the regulations. And their servers can be easily down, which compared to our Web3, like Ethereum network, is 100% up since Genesis. That gives us a counterintuition that, hey, we should have a safer world protected by Web3, But unfortunately, we still have a lot of places that suffer from the centralized component attack with single point failure. Besides the server being centralized front-end being replaced by the attackers, there are also a lot of attacks. Here I just name a few. Actually, this is really not new. Actually, in the last previous cycle, we see a lot of these attacks, including censorship, DNS, IP hijacking, server attack. Each of these attacks can easily create millions of transactions, millions of dollars of loss. And for Bybit attack, is perhaps the largest one. So one naive idea to solve this problem is that why not be able to move all our front end onto the blockchain and protect it by the smart contract, so that now both the front end and also the corresponding application contract can be protected by the Ethereum network. In this way, we can have a lot of benefits. We can guarantee all the front-end files has integrity, which is the same as what the on-chain contract is. It cannot be changed unless the owner of the contract, which most likely is the same as the application contract, that would like to change. And second, it's transparent. In order to change a file, we have to submit on-chain transactions, which will be recorded onto our public ledger, and it will be immutable. And lastly, it guarantees 100% availability, so nobody is able to perform censorship attack, and the server, this website, will be 100% up, the same as the Ethereum network itself. So this sounds to be a cool idea, but why nobody is now deploying their front end onto the Ethereum's network? One key problem is that it's too expensive. So for example, putting 1 gigabyte of storage data on top of Ethereum network right now can easily cost more than $1 million US. Suppose I want to run a front end with a couple of, for example, 10 megabytes of data, that can easily cost me a couple of thousands or even more onto the Ethereum network. And this is definitely too expensive for a lot of front-end applications. So in this way, we would like to see how Ethereum is able to solve this problem in the future. And thanks to Ethereum scalability roadmap, Ethereum aims to scale its capability to process the transaction greatly, while called rollup approach. The basic idea is using off-chain computation with on-chain verification. With the introduction of the DA, now it will just cost a few subcents to process a single transaction and verify on-chain using a rollup approach. Will that be the end game? Will that solve the problem? Of course not. We still have a lot of missing pieces in order to achieve internet scale and fully decentralized Web3. Why? First of all, even with layer 2s, all those layer 2s using the standard fully replication storage model, which means that all the validator of layer 2 nodes have to store a full copy of the layer 2 data, which will be a general a few terabytes. Otherwise, nobody is able to verify the off-chain transaction validity. However, compared to our Web 2, for example, Twitter, it can generate more than 10 terabytes of data per day, which means that suppose we want to run a secure Twitter with censorship attack, without censorship attack, it will be able to run for a few days. And then we'll soon exhaust all the storage capacity of a layer 2. And second, suppose we want to push a lot of transactions, for example, front ends, also DeFi transaction on the layer 2, we're still facing the performance limits because of the Ethereum EVM sequential execution model. So on the right-hand side is the output from Ethereum Go Ethereum, which will also output the megagas per second that the Go Ethereum can process, which is about 100 megagas per second. Convert this number to our usual operations, for example, Uniswap V2 swap operations. It can only support up to 1,000 swap transactions. And so in this way, it's really hard to support global-wide internet scale applications using single layer 2 technologies. There's also a couple of other issues. Here I highlight a few. One is onboarding costs, where the Web3 users need to create a wallet and memorize their private keys carefully. Unlike Web 2, we can easily create an account, like a Gmail account or Tweets, using a cell phone or other basic authentication method, and then be able to send the first tweet or send the first email with just in a few seconds. The users need to also acquire the gas token in order to be able to perform the first transaction. There's a way to try to address the problem is to using airdrop to incentivize the user and pay their first transaction fee, pay their transaction fees. Unfortunately, because of the misalignment of the interests, those airdrops can be easily attacked by Sybils, which people create a lot of accounts and try to maximize their profit and then sell their token directly rather than running organic transaction on top of the network. And this is something we have to solve in order to enable massive scale. And lastly, even we have layer 2 technologies with some, for example, ZK fraud proof and also fraud proof algorithms, it still takes significant high cost to validate these off-chain transactions. The validity proof can verify off-chain transaction immediately, but require expensive prover to prove off-chain transactions. And also, once the Ethereum has upgrades, it takes expensive and time to audit the new circuits. This cost called EVM upgrade scary. And fraud proof is able to alleviate the prover cost, but it needs high on-chain interaction transactions. Like, for example, Optimism right now requires 75 on-chain transactions in order to narrow down which instruction that off-chain execution is incorrect. And this results in long withdrawal window and also high on-chain transaction cost. So to summarize, in order to achieve an internet scale, fully decentralized world, we still have a lot of things to be done. First, we need to address the centralized front end. We need to bring the Web3 trust also to our centralized front end. And second, we need to have a greatly scale, natively storage capacity built on top of Ethereum. And we also need to improve the EVM performance so that we are able to serve internet scale applications. And we also want to bring almost the same Web 2 user onboarding experience on top of Web 3, so the users just need to spend a few minutes to be able to send their first Web 3 transactions. And lastly, we should reduce the validation cost so that we are able to quickly settle the layer 2 transactions within hopefully in a few days or even a couple hours. So with all these problems in our head, we introduced the Superworld Computer projects. It's built on top of Ethereum Layer 2 technologies, on top of OB Stack, with a lot of customization, so that it can enable a lot of new fully decentralized applications on top of Ethereum. So this is the overview of the Superworld Computer project. So in order to address the centralized front end, we have drafted the EIP 4804 Web3 Access Protocol, which is a protocol that is able to access on-chain resources and be able to verify the corresponding resources using called light client verification. So that now we can using Ethereum as a decentralized HTTP server and be able to render those dynamic contents thanks to the power of smart contracts. Second, to address the storage limitation problem, we are working on the EthStorage, which is also supported by Ethereum Ecosystem Grant Program. So that now we are able to scale the storage using off-chain storage and on-chain storage proof of verification, which is another direction of Layer 2. And for EVM performance, we are working on high-performance EVM with parallel execution and IOs. And to reduce the onboarding cost, we are working on account abstraction that is EIP 7702 together with Zhou gas token. Lastly, we are working on advanced fraud proof algorithms with the support of optimism to address the validation cost on Layer 1. So here, for the Web3 access protocol, what it looks like is just turns the EVM into an unstoppable HTTP server. It's very similar to HTTP, but just translate a HTTP-like link to a smart contract call and ask smart contract how to represent the front end with corresponding request. So the standard is being finalized as ERC 4804, and we have the gateway and EVM app browsers that are available, created by our community members. And we also maintain a copy of a Vitalik blog, and all our front ends are now also hosted using a Web3 access protocol that is also deployed on chain. And we are building the EthStorage, which is a modular storage layer, so that we are able to support petabytes of storage capacity, and without changing the Ethereum consensus layer, so that it can achieve minimum trust, permissionless, and modular. And it will be able to run as Layer 3, so that we can support petabytes capacity applications, so that we can, for example, even deploy on-chain trades on top of the Ethereum network. We are working on high-performance EVM to optimize the IOs. And EIP 7702, that's one of the most exciting EIP for the following Ethereum package upgrade. We are one of the early team to contribute to the EIP 7702, and here's a demo to using the ERC token to pay gas. And so gas token is another idea that we propose to airdrop non-transferable token to the user account. You can imagine it's just like Web2 credits, but it's able to pay Ethereum transaction fee rather than just transfer and sell the token directly. In this way, our target is to be able to airdrop hundreds of millions of accounts, including Web2 and Web3 users, with minimum cost. And for the advanced fraud proof, we are all working on the EIP 4844 blob to carry intermediate states to fastly settle down the fraud proof, and with the support of OP grants. So with all these solutions, we are now working towards the superworld computer be able to serve the fully on-chain applications. And here's the progress. We have a public testnet that's ready in this month. Feel free to check out our documents and go through the details of how to run a node. We also contribute some of the code to the OP stack. And EthStorage is also deployed on top of Ethereum supported testnet and our superworld computer Layer 2, so that you can also run your applications front end, for example, safe on top of that. We also offer 20,000 grants during the ETHDenver hackathon, so that you can experiment all these fancy ideas and be able to demonstrate your innovations and receive the corresponding rewards. And with all this, we can enable a lot of powerful fully on-chain applications, including fully on-chain AI. Even we can move the hood GitHub on top of the Ethereum network. And fully on-chain WordPress, or all these crazy ideas are now be possible on top of the full Ethereum Layer 1, Layer 2 network. There's a couple of new directions. For example, how we are able to integrate all the protocols, Web3 access protocol, into the browser, so that you can automatically verify all the content from the on-chain. And also how we are able to decentralize access to Ethereum, so that we don't need to worry about censorship attack, like, for example, like Infura may perform. So we are working with the Ethereum project called Ethereum Portal Network that address all these problems in a fundamental way. So many thanks for attending my today's talk. And if you have any questions regarding, for example, how do we solve the problem and how the technology works, feel free to reach out to me. Again, thanks again for attending my talk. Bye-bye.